We're now going to take the first derivative and get the candidates, as well as the second derivative, get the candidates for relative max, relative min, and point of inflection. We're going to say, what is that? I call this f, but in the book it was called c. So let me change it to c. It's a cost function, the way they gave it, c of x. I'm going to say c prime of x equals 0. What's c prime of x? C prime of x is 3x squared minus 2 times 3 halves x minus 18 equals 0. So this cancels out. I have 3x squared minus 3x minus 18 equals 0. This can be factored. First I pull out a 3. Then I have x squared minus x minus 6 equals 0. And that can be factored easily as x minus 3 times x plus 2 equals 0. There's a principle called the zero principle, which basically says if you're multiplying two numbers and the answer is 0, then at least one of the numbers, possibly both of them, were 0. Since this is a number, even though it's not written as a number, it's an algebraic expression, but x minus 3 is a number, x plus 2 is a number, one of them has to be 0. So by the zero principle,
Right.
write by ZP, yes?
We were worried about that 3 earlier. You said you just multiply that by a third and this side by a third.
You don't
and
need
this.
to do that. It's not necessary.
Right, because
that's.
it's.
I'm simply factoring this expression. This is what
So
c prime of x
if you're multiplying two numbers or more, and it says equal to 0.
Yes.
Okay.
Zero principle can be applied again and again. So by the zero principle, x minus 3 equals 0, or x plus 2 equals 0. You could indeed multiply it by a third if it's not necessary. This thing is an entire number, and
Right.
either this is 0 or this
That's
is 0.
an entire number.
And
Right.
if this entire thing is 0 and this isn't, then this would be 0.
Right.
So it goes to the same thing. And this means x equals 3, or x equals negative 2. So we have two candidates for relative max and relative min. X equals 3 and x equals negative 2. And we have to see what is going on here. So we're going to try graphing and computing certain things, see what happens. The first thing we want to try doing is we want to find what would the corresponding y value be. That is, what would the relative max and min be? That is the y value. The x value is the critical value, that is 3 and negative 2. What is the y value at this point? So if x is negative 2, what would y be? So this we can put, this would be negative 2 squared, or 4. 3 times 4 is 12. So let's go back here. Better, it's even better to put it in here.
Where do we plug it into? We plug the value into the original?
No.
Or the derivative?
I wanted to plug into the original and make a mistake. Thank you. If I put
Sorry,
it here, I get 0. I put it in the original.
Right.
Let's put negative 2 in here. This then become 8. This is minus 3 halves times 4, minus 18 times negative 2 plus 5. So this becomes negative 6. So 8 minus 6 is 2, plus 36. It's going to be 38. I'm sorry. This is negative 8 because I put in negative 6. Negative 8 and negative 6 is negative 14, plus 36 is 22, plus 5 is 27. So if I put in negative 2 for x, it's negative 8. 3 halves times 4, minus 6, it's minus 14, plus 36 is 22, plus 5 is 27. Now I'm going to put in the value for y, the other value, which is going to be 3. If I put in 3 here, this becomes 27. Becomes minus 3 halves times 9. Minus 18 times 3 is minus 54, plus 5. So 27 and 5 is 32. If I subtract, this is 27 and a half. This is 27 halves. These 27 halves are 13 and a half. So I have 32 minus 13 and a half. It's going to be 18 and a half. I add, and then I'm also subtracting 54. So I subtract 54. So I get 5. I don't want to do this. I'd rather write this as 18. I'd rather call this 37 half. I'd rather do this in halves. I'm sorry. It's easier to compute it more accurately.
That's right.
I'm going to call this 54 over 2 minus 27 over 2 minus 108 over 2 plus 10 over 2. Put it all in halves. So 54 plus 10 is going to be 64 over 2. And 27 and 108 is minus 135 over 2. Subtract them. I think I get minus 71 over 2. Because 71 and 64 is 135. So it's minus 71 over 2, which is minus 30 and 1/2. So if I put in x is 3, y is minus 30 and 1/2.
Is that 35 and a half?
Did I say 30?
Yeah, 35, right?
Sorry, the correct answer is 35 and 1/2. Okay, making little mistakes. It's important to get sleep. Minus 35 and 1/2. Thank you for your help, Cameron and Steve. It's minus 35 and 1/2.
That's what I'm here for.
Very good. So we have, on our graph, if we were to draw a graph of this initial thing, let's try drawing a graph over here, we would have these 2 points. We would have negative 227. Negative 227 is way up there. This is negative 227. And we have way down on the right somewhere here, 3. 1, 2, 3. 3. That's like 3 minus 35 and 1/2. Now, it really doesn't, you might think this is relative max, this is relative minimum. It's certainly possible, but it doesn't have to be that way, because theoretically there could be a higher point there and a lower point here, or there could even be a higher point on this side. However, since we know that these are only 2 points, there cannot be in that vicinity something different. We wanted to graph some more points and do some more work on it, and we will try doing something else to make the determination. Before we do more, let's get the point, what might be a possible point of inflection. Possible point of inflection means C double prime of x equals 0. Since this is C prime, C double prime is going to be 6x minus 3 equals 0. Factor out the 3. 3 times x minus 1, 2x minus 1 equals 0. That means 2x equals 1, so x equals 1/2. So if x equals 1/2, let's see what y would be. Put in 1/2 for x, divisional equation. We have over here, this would be 1/8 minus 3/2 times the 4th minus 1/2 times, this is 1/2 times 18 is minus 9 plus 5. This is equal to, change this all to 8s. This is 1/8 minus 3/8. 1/8 minus 3/8, that's going to be negative 2/8. We'll change this all to 4. So this is negative 1/4. Minus 9 is minus 36 over 4. Plus 5 is plus 20 over 4. So it's minus 37 plus 20, which is minus 17 over 4, which is minus 4 1/4. So we have over here the point minus 4 1/4. So we have right here 1/2, right here is the 1/2, and minus 4 1/4 is right there. That's very likely to be a point of inflection. If so, that gives us the possibility of suggesting, we're not through yet, that's a relative maximum, and it's concave down here. Then over here is a relative minimum, starts becoming concave up. So this concave up, from here on out is concave up, from there to the left is concave down. That's what we suggest just from these graphs, but we have more to go before we can say for sure. Those 3 points, that's already a good suggestion. Let us now look at this more closely. We're going to focus on the equation over here.
Great.